Good morning, students. Today we are going to discuss optical instruments. You do have two optical instruments in your syllabus. One is your microscope, another one is your telescope. Now today we are going to discuss microscope. Now all of you know microscope basically used to see an object whose dimension is very less. Basically it forms a magnified image. Now under microscope there is a classification. One is your simple microscope, another one is your compound microscope. Now in the simple microscope is nothing but your magnifying glass, and compound microscope is nothing but is your instrument which is used basically in biology lab, to see the microscopic objects. Now initially let me start with the topic simple microscope, which is nothing but is your magnifying glass. Now you see here it is a convex lens, and an object is placed in front of the convex lens. Now the object should be within the focus of the convex lens. So AB is your object which is placed within the focus of the convex lens. Now all of you know when an object is placed within the focus of a convex lens, basically it forms virtual image. So let me write this part, you can consider F. Okay, and AB is your object within the focus of the convex lens. Now AB is your object, and here we have got the magnifying image A dash B dash. Now the distance of the object AB from the optical center of the lens is your U, and A dash B dash is your image which is formed at the least distance of distinction. Now all of you know what is least distance of distinction. This is the distance at which we can see an object very distinctly, and for normal eye it is 25 centimeter. So A dash B dash is placed or A dash B dash is formed at a least distance of distinction. Now in exam basically related to the microscope, ray diagram and the magnifying power it is asked to define. Now ray diagram is this one, and magnifying power, to define magnifying power of simple microscope we must have to know the definition of magnifying power. So here you see as per we have written, magnifying power of a simple microscope is defined as the ratio of the angle subtended by the image and the object when both are at the least distance of distinction. Now you see both object and image should be at the least distance of distinction, is not it, if you want to define magnifying power, and it is nothing but the ratio of the angle subtended. Now you see, if you see this figure, the image A dash B dash makes an angle beta. Now this image is at the least distance of distinction. Now if you want to place the object at the least distance of distinction geometrically, what we have to do, we have to extend the rays, or we have to extend the line, and we have extended B is extended till M, so A dash M, and the ray makes an angle alpha with the principal axis. Now beta is the angle made by the image and alpha is the angle made by the object when both are at the least distance of distinction. Now as the angle is very small, that's why you can consider 10 tangent of the angle. So beta equal to 10 beta and alpha equal to 10 alpha. So if you have to define 10 beta, here AB by OA. So let's see, 10 beta is your AB by OA, and 10 alpha is your A dash M by OA dash. A dash M by OA dash. But A dash M and AB is same, that's why we have written AB in place of A dash M. And once we have written, so what happened basically, it gets cancelled out and you do have OA dash by OA. Now OA dash is your distance of the image which is formed at the least distance of distinction. So if you maintain the sign convention, you must have to move as per the opposite to the direction of the arrow. That's why it is negative. So it is your minus D by minus U. OA dash is your minus D and OA is your minus U. So minus D by minus U gives you D by U. Now in the lens formula, you know the lens formula, 1 by v minus 1 by u equal to 1 by f. So in place of v, we are substituting the least distance of distinction, that is your minus d, and in place of u we have placed minus u, so it comes here 1 by u plus u. So minus 1 by d plus 1 by u equal to 1 by f. So if you multiply throughout by d, it becomes easier minus 1 plus d by u equal to d by f. So d by u equal to 1 plus d by f. So this is your number 2, and number 1 magnifying power is your d by u. So from 1 and 2 you can say the magnifying power of simple microscope is your 1 plus d by f. So in numerical we are going to use this formula 1 plus d by f, where d is the least distance of distinction and f is the focal length of the convex lens. Basically simple microscope is nothing but is your magnifying glass. Now next topic which you are going to define is your compound microscope. Now you see, in compound microscope you need two lenses. One is in front of the object, which is defined as your objective. So here this one is your objective because this is your object, and this one is your eyepiece because it is near the eye. So you see this diagram, AB is an object placed, and the distance is your u naught. So A moves parallel to the principal axis and passes through the lens and intersect on the principal axis at f naught. Now another ray passes through the optical center and it goes undeviated and intersects at b dash. So b dash you will get an image b dash a dash. Now you see AB is an object and a dash b dash is the image formed by the convex lens, which you define as your objective. Now this image is little bit magnified compared to AB. Now this one is have to be magnified further, and for that there is an eyepiece. Now this a dash b dash is placed within the focus of the eyepiece, that is your f suffix e, and that's why we are getting further magnified image a double dash b double dash. Okay, now you see this figure, 2 times magnification occurs for the object AB. That's why in compound microscope we used to get highly magnified image, and the final image is formed at the least distance of distinction, which we define as your D. Now O suffix for objective and E suffix for eyepiece. So object distance u naught and v naught is your image distance for objective, and for eyepiece u suffix e is your object distance and v suffix e or d is the image distance. Now as per the magnifying power, what we have to do is, again we have to go for the definition. It is the ratio of the angle subtended by the image to the object when both are at the least distance of distinction. So a double dash b double dash is at the least distance of distinction, and the angle made by is your beta. Now if you have to place the object at the least distance of distinction, you have to go for geometry part. So you have to extend the ray which moves parallel to the principal axis from AB, and you have to place that is a double dash m. A double dash m is nothing but is your AB, and it is placed at the least distance of distinction where the final image is there, and the angle is your alpha makes with the optical center O2. Now as per the definition, magnifying power is your beta by alpha, so 10 beta by 10 alpha. So if you go for 10 beta, you will get a double dash b double dash by O2 a double dash, and for 10 alpha a double dash m O2 a double dash. Now a double dash b double dash O2 a double dash O2 a double dash goes off, so a double dash b double dash by a double dash m. A double dash m is nothing but is your AB, so a double dash b double dash by AB. So what we will do here, we will simplify by multiplying a dash b dash, numerator and denominator. So a double dash b double dash by a dash b dash, this gives you the magnification for eyepiece as per the definition, because for eyepiece a double dash b double dash is the image and a dash b dash is your object, and for a dash b dash by AB gives you the magnification for objective, that is your a dash b dash by AB. So magnifying power is nothing but the product of the magnification for eyepiece as well as magnification for objective. Now magnification for objective, that is your as we have written a dash b dash by ab. So a dash b dash by ab. So if you consider ABO1 and a dash b dash O1, two triangles are similar, and under that case you will get the sides are proportional. So you will get m naught is your nothing but is your v naught by minus u naught, and in place of eyepiece, a double dash b double dash by a dash b dash. So me a double dash b double dash by a dash b dash. So here you will get that is your v by ue, both negative, that's why cancel out. So d by ue. Now if you use the lens formula, you will get 1 by v minus 1 by 1 by f, and if you have to apply this one in eyepiece lens, so it should be your minus 1 by v minus ue, that is plus 1 by ue and 1 by fe. So basically lens second focus is considered. So it comes out to be your v is nothing but is your d, so minus 1 by d plus 1 by ue plus equal to 1 by fe. So if you simplify multiplying by d, then minus 1 plus d by ue d by fe, so d by ue 1 plus d by fe. So you see we are getting me, that is 1 plus d by fe from 3. So magnifying power, that is your m naught minus v naught by u naught 1 plus d by fe. Now capital L is the length of the microscope. Microscope length is nothing but the distance between the two lenses. So if you consider the distance between the two lenses, it is your v naught plus ue. So capital L is nothing but is your v naught plus ue. Now another ray diagram we are considering for compound microscope by considering the final image is formed at infinity. So this is your ray diagram. For that, what we have to do, the image of the object AB found by the objective lens should be at the focus of the eyepiece. So if it is at the focus of the eyepiece, then you will get image is at infinity. So let me try to find out magnifying power. So magnifying power is your m naught me. So for objective it is remain same. For eyepiece me, that is your we are going to use this one. So in place of ue, it should be your fe, d by fe. So magnifying power minus v naught by u naught d by fe. So if it is the length of the microscope, then it is your v naught plus fe. So please try to go for this expression part as well as the ray diagram. In exam, basically it is used to draw the ray diagram and ask to find out the magnifying power. So please go through, and in any reference book you will get this one, and also in textbook you will get. So microscope part is your simple microscope and compound microscope, and these are the ray diagram, and in exam you will get the question from this part only. So please go through. Let me to show you the ray diagram once again. This is one ray diagram for simple microscope. This is your ray diagram for compound microscope. Try to check it out. And this is another ray diagram for compound microscope, considering the final image is formed at infinity. So this is all about from the optical instrument, one instrument, that is your microscope, and next class we are going to go discuss for the telescope part. So this is all about. Thank you.